Okay, today we're going over 7.3 binomial radical expressions. So today we're going to be looking at like radicals, and in order for it to be like radicals, they need to have the same index and the same radicand. So the index is going to be written right here in the radical, and the radicand is the number or the variable underneath the radical sign. So, for example, if we take 5 cube root of x minus 3 cube root of x, these are like radicals because they have the same index, 3, and the same radicand, x. So then what we're going to do is we're going to subtract our coefficients and keep the like radical. It's very similar to like terms. If I have a 5x minus a 3x, then we know that's equal to 5 minus 3. We subtract the coefficients, 2, and we keep the variable. So it's a 2x. So we're going to do something similar here. We're going to subtract the coefficients. 5 minus 3 is a 2. And then we keep the like radical, cube root of x. And that's your answer for this problem here. If we have ones where they don't start off being like radicals, we can simplify them and see if we can get it down to having like radicals. For example, if I have 6 square root of 18 plus 4 square root of 8 minus 3 square root of 72, then we can simplify all of these. I can break up the square root of 18 by saying, what is a perfect square that goes into 18? 9 is a perfect square and it also goes into 18. So 9 times 2 will give me 18. We'll break up the square root of 8 as the square root of 4, because the square root of 4 is a perfect square and it also goes into 8. 4 times 2 will give me 8. And we'll break up the square root of 72 as 36 into, because 36 is a perfect square and it also goes into 72. So then we'll simplify this a little bit more. We'll go square root of 9 is a 3. The square root of 4 is a 2. And then just bringing everything else down. And the square root of 36 is 6. So multiplying these out, 6 times 3 is an 18, square root of 2. 4 times 2 is an 8, square root of 2. And 3 times 6 is an 18, square root of 2. Simplifying these, just like the previous example, we get 18 square root of 2 minus 18 square root of 2 will cancel, and therefore we're left with an 8 square root of 2. Okay, moving on to multiplying binomial radical expressions. So we know that if we have two binomials and we're multiplying them, we use the FOIL method, which just stands for first, outer, inner, and last. So let's say we have 3 plus 2 radical 5 times 2 plus 4 radical 5. So we have two binomials and we're multiplying them. So we're going to FOIL. First, outer, inner, last. So we go, first terms are 3 and 2. 3 times 2 is a 6. Outer terms, the 3 and the 4 square root of 5. So 3 times a 4 is a 12 square root of 5, because we multiply the part that is going to be the rational numbers, and then we'll multiply the parts that are irrational. Inner is 2 times 2 is a 4 square root of 5. And last, 2 times 4 is an 8. Square root of 5 times square root of 5 is a 5, and that's because the square root of 5 times the square root of 5 is the square root of 25, which is just 5. Okay, now we can combine our like terms here. We have 12 square root of 5 plus 4 square root of 5 is going to be 16 square root of 5. 8 times 5 is a 40. Adding our numbers, our rational numbers, 6 plus 40 is a 46 plus 16 square root of 5. And that's simplified for multiplying binomial radical expressions. Moving on here, let's talk about some conjugates. So if we remember from previous lessons, if we have conjugates, that means, for example, if I have 2 plus the square root of 3, the conjugate of this is going to just be changing the sign of the second term. So that's all a conjugate changes. So the conjugate of this, of 2 plus square root of 3, is 2 minus square root of 3. The only thing that changes is the second term sign. Not all of the signs change. If you change all of the signs, then that would be the opposite. But we're looking at the conjugate, which only changes the second term. Okay, so if we actually multiply these out, if we're multiplying conjugates and we try and FOIL, what's going to happen is the outer and the inner will always cancel out, which means you only have to multiply the first and the last terms when they are conjugates. So we'll multiply the first, 2 times 2 is a 4, and the last, square root of 3 times negative square root of 3, positive times a negative is a negative, square root of 3 times the square root of 3 is a 3. 4 minus 3 is a 1. And if you notice here, we started with the square root and we no longer have any square roots in our answer. So that will then lead us to multiplying out and trying to rationalize the denominator when we have binomial radical denominators. For example, if we have a 3 plus the square root of 5, and we're dividing that by 1 minus the square root of 5, in order to rationalize binomial radical denominators, such as this, I want to get rid of the square root in the denominator, which means I'm going to multiply by the conjugate of the denominator. And the conjugate only changes the second term, the sign of the second term. So we're going to multiply the top and bottom by 1 plus the square root of 5. 1 plus the square root of 5. So we know that the denominators are conjugates. So since these are conjugates, I only have to multiply the first, 1 times 1 is 1, and the last terms, a negative times a positive is a negative, the square root of 5 times the square root of 5 is 5. The numerators are not conjugates, so I do have to FOIL the entire numerator out. So I'll go first, 3 times 1 is a 3. Outer, 3 times the square root of 5 is a 3 square root of 5. Inner, 1 times square root of 5 is plus square root of 5. And last, the square root of 5 times the square root of 5 is 5. Now I can simplify this here by adding my rational numbers. 3 plus 5 is 8. And my like radicals. 3 square root of 5 plus square root of 5 is 4 square root of 5, because if there's no number in front of the radical, it's just a 1. And then it's all over 1 minus 5, which is a negative 4. We know that from here, I'm going to divide each term by negative 4. So if it helps, you can write it out as 8 over negative 4 plus 4 square root of 5 over negative 4. And that's just to show you that you're dividing every term by negative 4. And therefore we get a 8 divided by negative 4 is a negative 2. 4 divided by negative 4 is a negative 1 square root of 5. And that is our final answer. And that is the end of 7.3, which is going over binomial radical expressions.